Consider this. The most complex object in the known universe isn't a distant galaxy or a black hole. It's resting right between your ears. It's a 3-pound universe of flesh, a silent, wet cosmos of its own, pulsing with an electrical storm more intricate than any power grid on Earth. This is your brain. And right now, as you hear these words, it's performing a magic trick so seamless, so utterly profound, that we are only beginning to grasp its rules. It's translating squiggles of light on a screen or vibrations of sound in the air into ideas, into emotion, into understanding. It's weaving your reality from threads of electricity and chemistry. But how? How does this silent, hidden organ, this lump of tissue, create the symphony of a thought, the vivid panorama of a memory, the spark of consciousness that is you? We are about to go on a journey into the last great frontier, the space inside our own heads. We often think of the brain as a single mysterious command center, but it's more accurate to think of it as a city of almost 100 billion citizens called neurons. And each of these citizens is a world unto itself, a tiny biological tree with a root-like body, branching arms called dendrites, and a single, long tail called an axon. Here's the crazy cool part. This city never sleeps. It is alive with constant conversation. Those billions of neurons are not just sitting there. They are talking to each other. Not with words, but with pulses of electricity and tiny puffs of chemicals. When one neuron gets excited enough, it sends a lightning-fast electrical pulse down its axon. When that pulse reaches the end, it triggers the release of chemical messengers, neurotransmitters, which leap across a microscopic gap called a synapse. They land on the dendrites of the next neuron, like a key in a lock, and the message is passed on. This is the fundamental language of thought. Every memory you cherish, every skill you've mastered, every fleeting feeling of love or joy or fear is written in this dialect of sparks and chemicals, in the trillions upon trillions of connections that weave this neural city together. To navigate this city, we need a map. Let's start with the brain's most iconic feature, its wrinkled walnut-like surface. This is the cerebral cortex, the seat of our highest functions. It's divided into lobes, each a specialized district. At the very back is the occipital lobe, the visual processing center. It's here that raw data from your eyes is assembled into lines, shapes, colors, and finally, into the recognizable image of a face or a sunset. Up on the sides, nestled above your ears, are the temporal lobes. These are the archivists. They are deeply involved in memory, especially the formation of new long-term memories, and in understanding language and recognizing sounds. When you hear a familiar song and are instantly flooded with nostalgia, you're feeling the work of your temporal lobes. Moving forward, we find the parietal lobes running over the top and back of your head. This is your sensory integration and spatial reasoning headquarters. It takes the touch signals from your skin and the position signals from your muscles and creates your sense of physical self, your awareness of where your body is in space. When you effortlessly catch a ball or navigate a crowded room without bumping into anyone, thank your parietal lobes. And at the very front, right behind your forehead, is the crown jewel of human evolution, the frontal lobes. This is the executive suite. This is where planning happens, where decisions are made, where impulse is controlled, where personality is shaped. It's what allows you to set a goal, resist a distraction, and imagine a future different from your present. It is, in many ways, the seat of our humanity. But the story isn't just on the surface. Beneath the cortex lie older, deeper structures, the ancient foundations of our brain city. There's the limbic system, our emotional core. This includes the amygdala, a tiny, almond-shaped alarm system that processes fear and triggers our fight-or-flight response before our conscious mind even knows what's happening. And there's the hippocampus, a seahorse-shaped structure crucial for forming new memories and navigating space. It's the brain's librarian, taking new experiences and deciding which ones to file away into the permanent stacks of the cortex. Then, at the very base of the brain, sits the brainstem, a stalk that connects to the spinal cord. This is the life support system, regulating heartbeat, breathing, and sleep cycles automatically, 24/7. It's the ancient, vital engine room that keeps the lights on so the rest of the city can think and dream. Now, let's talk about the brain's most astonishing superpower, its ability to change. For most of history, we believed the brain was hardwired after childhood, a static, finished machine. We were completely wrong. The brain possesses a quality called neuroplasticity. It means the brain is plastic, malleable, capable of reshaping itself throughout our lives. Here's the wild part. Every time you learn something new, a fact, a skill, a route to work, you are physically rewiring your brain. The connections between neurons, those synapses, are strengthening or weakening. New branches can sprout on dendrites. It's a process of constant renovation. When a London taxi driver memorizes the city's labyrinthine streets, the part of their hippocampus devoted to spatial memory actually grows larger. When a pianist practices a sonata for thousands of hours, The motor cortex regions controlling the fingers become more finely mapped. Your brain's structure is a living record of everything you've ever done, learned, and practiced. You are, quite literally, sculpting your own mind with your daily choices. This brings us to one of the brain's most elusive and essential functions, memory. How does the brain take a fleeting experience, the taste of your grandmother's pie, the feeling of a first kiss, and etch it into the physical fabric of neurons? It's a multi-step process. First, sensory information is held for seconds in short-term memory, a kind of mental scratchpad. If it's deemed important, often through emotional charge or repetition, the hippocampus gets to work. It orchestrates a kind of neural concert, strengthening the connections between the various cortical neurons that hold the sight, sound, smell, and emotion of the event. Over time, through a process called consolidation, this memory becomes less dependent on the hippocampus and is stored more permanently across the wide networks of the cortex. Think of the hippocampus as a construction foreman, organizing the workers to build a memory, and the cortex as the vast library where the finished memory is shelved. But memory isn't a perfect recording. Every time we recall a memory, we potentially alter it slightly, reconsolidating it with the filters of our present self. Our past is not a fixed film. It's a story we subtly rewrite each time we tell it to ourselves. For centuries, our understanding of this incredible organ was guesswork, based on studying injuries and diseases. The story of Phineas Gage is a famous, tragic example. In 1848, a railroad construction foreman had a tamping iron blasted through his frontal lobe in an explosion. Miraculously, he survived, but the man who emerged was not the man who went in. The responsible, diligent Gage became impulsive, profane, and incapable of planning. His friends said he was no longer Gage. This accident provided one of the first crude clues that different brain regions govern different aspects of our personality and mind. It was a horrifying but pivotal moment in neuroscience. Today, we are no longer limited to waiting for tragedy to strike. We have a window into the living, working brain. Technologies like fMRI, functional magnetic resonance imaging, let us watch the brain in action. By tracking blood flow, we can see which districts of the neurocity light up when someone looks at a picture, solves a math problem, or feels love. EEG caps can measure the brain's electrical chatter, the sum of millions of neuronal conversations, revealing the rhythms of sleep, focus, and meditation. We are mapping the geography of thought itself, learning which networks activate for creativity, which for focus, and which for mind wandering. And the discoveries are mind-blowing. We've learned that the brain is a champion of efficiency. It's not just a passive receiver of information. It's a relentless predictor. It's constantly building models of the world and guessing what will happen next. Most of what you perceive as reality is actually your brain's best guess based on past experience, which it then checks against incoming sensory data. This is why optical illusions work. Your brain's prediction overrides the actual data. Your conscious experience is a beautifully constructed simulation, a user interface created by your brain to help you navigate a complex world. We've also begun to unravel the deep connection between the body and the brain. The gut, with its own vast network of neurons, is in constant bidirectional communication with the head, influencing mood and decision-making in what's often called the gut feeling. We understand that sleep is not downtime. It's when the brain's janitorial and administrative staff come out. Cerebrospinal fluid flushes away toxic waste proteins that build up during the day, and the hippocampus replays the day's events, strengthening important memories and discarding the trivial. To skip sleep is to literally poison your mind and sabotage your memory. So, where is this all heading? What does the future of understanding the brain look like? You won't believe the frontiers we're approaching. We are entering the era of brain-computer interfaces, or BCs. Imagine a world where a paralyzed individual can control a robotic arm or type on a screen using only their thoughts, by decoding the intention signals from their motor cortex. This is not science fiction. It's in clinical trials today. The next step is two-way communication, sending sensory feedback into the brain, potentially allowing someone to feel the texture of a virtual object with a prosthetic hand. On the horizon are technologists that could map the connectome, the complete ultra-detailed wiring diagram of every single neuron and synapse in a brain. This would be like going from a crude map of a country's major highways to having a satellite image of every street, alley, and footpath in every city. The computational power needed is staggering, but the pursuit is underway. It could finally reveal the physical code of memory and personality. We are also developing advanced neuroimaging that can see not just where activity is, but what kind of activity it is, distinguishing the chemical signatures of different neurotransmitters in real time. This could revolutionize psychiatry, moving it from a trial-and-error approach to medication to a precise, targeted science based on an individual's unique brain chemistry. But with this incredible power comes profound questions, ethical dilemmas that loom larger every day. If we can decode a person's basic intentions from their brain signals, where do we draw the line on privacy? Could this technology one day be used to read thoughts against someone's will? If we can enhance memory or learning through direct brain stimulation, who gets access? Would it create an unbridgeable gap between the neuro-enhanced and everyone else? And the ultimate, haunting question, as we decode the mechanical processes of the brain, will we ever truly explain the phenomenon of consciousness, the subjective experience of being, the feeling of what it's like to see red or feel pain? Will we find the soul in the synapse, or will we discover that the self is the sum of its parts, a glorious, emergent illusion spun by a vast network of cells? We are the universe trying to understand itself. The 3-pound lump of tissue in our skulls is attempting to comprehend its own staggering complexity. Every discovery in neuroscience is a humbling reminder of both our fragility and our astounding potential. The brain is not a perfect machine. It is a messy, evolved, energy-hungry organ prone to biases, errors, and breakdowns. Yet, from this biological tangle arises art, science, compassion, and the relentless desire to explore. So the next time you have a flash of insight, get lost in a memory, or simply daydream, remember the silent, electric city at work. You are not just having a thought. You are witnessing a biological miracle, the product of billions of years of evolution playing out in an instant. The journey into the brain is the most personal voyage we can ever take. It's a journey to the very source of what makes us human. And the most astonishing discovery of all may be this. The more we learn about this incredible organ, the more we realize that the capacity for wonder, for curiosity, for all that very feeling driving this exploration is the brain's greatest creation of all. The story is being written by the very thing it's trying to understand.